truth table like that. So on the UP2 board, we have push buttons. We also have the dip switches. Okay. So the push buttons are red, blue in color, black in color. What about the dip switches?
Is that the white switches on the red part of the board?
Well, there are many switches. There are two of them. But one is for the max device, one is for the flex device. So right now you don't use the push button as your inputs. You use the switches as your input. Alright? Because we need more than two inputs. In this case, we need to have four. The inputs are from the dip switches, and then the LEDs. Right now, they're not the discrete LEDs. They are 7-second display. So if you play with the dip switches, you are going to have these combinations, and then the corresponding 7-second display should show these digits. Okay? So some of them are lowercase, some of them are uppercase. Okay? So it's similar to the first assignment, but you get more combination in the view. Understand? But the requirement for this assignment is to use the STD logic vector. So today we'll go over the concept of STD logic vector. We have learned to use STD logic. So what is a vector? All right? Any question about what we need to do for assignment number 2? Let's look at STD vector. So we're going to create a brand new project to demonstrate this idea. This is our third example. This is example from example number 1. 1 or 2. Example 2. So now 3, 3, and now so look at this, you realize you have 2 inputs, 4 outputs. Okay? If you have 1,000 inputs, you put out 1,000 lines of code. That's rough. Right? In digital circuits, most of the time, you can group the inputs together. When you group them, we'll call it a bus. So you can group the inputs together, you can group the outputs together. And there's really no limit of how many members you can put in the bus. You have 2 minimum, because when we have 1, that means it's not a bus, it's only a single input. So 2 minimum, and there's really no upper limit. Once you have a bus, that means you can work with the bus instead of work with individual inputs. Now, if you look at this code, you can easily spot that we can actually put them into 2 buses. One bus for the inputs, which contains the push buttons. One bus are the LEDs, which has 4 members. Okay? So to do that, we have to use what we call STD vector. Okay? STD logic vector. So if you have single bit, it's STD logic. You have STD logic vector, that means multiple bits. Okay? So we're going to change this to a vector. when you specify the vector, you also have to put down exactly how many members you're going to have. Okay? The tool doesn't really care about whether you get 1, 2, 2, 3, or 0, 1. Understand? Because 1, 2, you get 2 members. 2, 3, you also get 2 members. 0, 1, you get 2 members. Okay? However, a convention is usually we start with 0. So 0, 1 is 2 members. 0, 1, 2, 3 members. 0, 1, 2, 3, 4 members. Okay? So for inputs, push buttons, we have how many members? 2. So you get 1, you get 0. Right? You need to tell the tool which one is more significant. Okay? Of course, in this case, 0 is least significant and 1 is most significant. So you put down 2. So this is a keyword. This means I have member from 1 to 0. That means 1 is more significant. You always put the more significant as higher number. Okay? You cannot write 0 down to 1. It does not make any sense. Understand? Okay? So, yes?
I don't believe in push button.
This is an example.
Just checking.
Just answer. The push buttons, now we do not discriminate between push button 1 and 0 anymore because we group them into a bus. Okay? So instead of naming it push button 1, you should just name it push button. And then we can remove this line. Because right now, this bus has 2 push buttons, 1 and 0. 2 members. Understand? Alright. So what do we do with this? Same thing. LEDs. We get 4 members. Vector, what should I put down here?
3 down to 0.
Exactly. 3 down to 0. Okay? Remember, no semicolon. This is what we have. So right now, we compact the code into 2 lines of inputs instead of 2 plus 4. Okay? Alright. So now we need to deal with the architecture, which specifies the operation. Now, 0 used to be a single bit input, so a single bit output. So right now it's a bus. So if you want to tell the tool, I want to only work with member 0, what you need to do is this syntax. See that? So this tell the tool, I'm looking at the bus, but only look at the last bit, which is bit 0. Okay? So how would I change this line? That's right. 2, 3. Okay? 1, 2, and 3. So we're done with the outputs. Let's look at the inputs. PB1 used to be a single bit. Right now it is 1 member of a bus. So that means this has to be parentheses 1. That's correct. Okay. So this whole thing represents PB1. So that means this is PB1, PB1, PB1. And what about PB0? This will be PB bus member 0. So now this has to be changed because we don't have PB1 anymore. We have PB, which is the bus. So this whole code is rewritten using STD logic vector. So we compile the project. Before it works, we just rewrote the code using different style. So far, any questions about the bus, the members? In the future, all assignments starting from today, if you see a bus, please use the vector. Okay? We don't want to deal with individual bits. we can deal with the bus, we deal with the bus. Okay. All right, let's continue about the simulation. Close this. Simulation report. How come? No problem. I'm going to create one. So here I want to talk about what we expect to see. So pins, all pins. Alright, so look at this. If you have individual pins, they'll show you individual input and output. But here you can see that it shows you something plus the members. See that? The members. This means member 0 of the bus. So if you throw this on the waveform, it's only one bit. It's not the whole bus. This is the whole bus. See that? This is the entire bus. This is only one of the bits. So when you simulate a bus, you don't want to use this form. You want to use this. Understand? So let's add that. Add that. We have inputs first and then output. Alright. Save this. And this is going to be our simulation waveform. Alright. From tutorial number 2, we learned if you have a bus, we can count all the sequence. Tutorial number 2. So now what we're going to do is we're going to go through all the sequence for PB bus, the push buttons. So the push buttons can be 0, 0, 0, 1, 1, 0, 1, 1. These are all full combination you can have. You cannot have anything else. Okay? So let's increase the end time. Let's make it 8 microseconds. This is our count value. Count value. So binary, starting value is 0, 0, ending value is 1, 1, increment by 1. I want to count every 1 microsecond. Okay, so these are all the combinations for my inputs. So 0, 0, 0, 1, 1, 0, 1, 1, and repeat one more time. Okay? Output, we want to make sure that we're also looking at binary. Okay, so right now, you can see that XXXX means I don't know the value because you have not run the simulation yet. Save, run the simulation.